that means 1 minute, and I send. You can see the system confirms that I've sent the duration to 1 minute. So let me just clear the terminal to clearance so I can click on this. Then I want to set the time in which the system will kick in. You can see currently the system is off. You can see it's currently off. So I'll go ahead and set the time in which to start working. So I'll set the time like that. That's a command. So right now it's in the system it's 4:42, 16:42. So I put it aside to set it at 16:43. So we see what happens. So I sent and it says sleep time set to 16:43. Now here that's the time regarding to the system. So let we can see what happens when it reaches at 16:43. So, hello, can you hear me? Hello. Someone to confirm if they can hear me. Yes, someone to unmute their mic and confirm that you can hear me.
Yes, you're audible.
Okay, thank you for confirming. Um, let's give it a couple of minutes, see where let others join. Paul, are you with us? Paul. Okay, so in the meantime, I'll be discussing what you're going to be doing today. So today's session will be extremely short, as the topic of today is about how to use KariRS in the cloud, or even how to have a ready-made environment for usage for embedded development, which is something that is coming up, and it's very good to understand it and know how you can use it and apply it uh, in your work or in your project or elsewhere where you want to apply such kind of uh, technologies. So first thing is to understand. So literally, I won't be talking of the underlying technology of Docker or all that, but in the meantime, I just touch on it. I can just show you what we really mean before even going to KariRS. So when you hear the term Docker, it all comes to the it all comes to the point of what we call containerization. So if you can even Google what is containerization, I want just to take you through. So for someone who is completely new to even these concepts, they can understand what it is. So you can see if you search it, it tells you that containerization is a method of packaging an application along with dependencies, libraries, and configuration files into a single unit called a container. This ensures that the application runs consistently across different computing environments. So literally what we mean, let me show it with an let me show it with something where we can script something so we can write it out. Uh, yes, so let me share the full screen so we can Warren, you're welcome. So someone to confirm whether you can see my screen clearly, just unmute your mic and confirm, because while sharing the entire screen I can't see your gestures. Someone to unmute and confirm that they can see my screen clearly. Okay, thank you. So literally, what you're talking about today is about leveraging the cloud or cloud technologies to be able to do embedded development using them, or to even debug or write embedded code
in the cloud itself, or to even use those technologies. So literally, we've seen many other technologies such as web development. You have also seen apps being built in the cloud. And for someone who would be completely new and wondering what is cloud, I just want to assume maybe there's someone who even just has been hearing that word and they do not know what is the cloud. So literally, the cloud is just like saying you're using someone else's computer. So we have someone who has a computer, let's say computer A. You also have someone else's with computer B. So if these people decide that they have very powerful processors, or they and in most terms we call them servers because they are literally built for high computing usage, and they connect them to the internet and they start rendering services. They allow you to use their computers to do computations. So literally that's the fundamental basics of what the cloud is. So when you hear the term cloud, it's just you using someone else's resources or computation resources to do computations that your computer cannot do. And that is what we see big companies like, for example, AWS, we've seen Amazon, all these big companies, we have Google, all of them, they do offer this kind of services, and they also use them internally in their day-to-day businesses and their work. So literally now, to back to us, who we are here, our if you look at what we do in embedded development, we have you have your PC and you have to connect it to your microcontroller, your MCU. And so after you write your code, you then send it to the MCU. So literally you need access to the hardware. But you only need the MCU when you are uploading your code. You only need your MCU when you are literally uploading your code. So if you aren't uploading your code at that particular moment, you aren't even using your MCU. So that is what we want to take and say during the time that you are writing your code, or you just want to test a new framework. For example, the way KariRS is new and we want to test it and write its code, we can leverage the cloud. I don't need to have a computer which is able to run all those Rust dependencies and run all those the Rust compiler and something. We want to allow someone who even has less resources, or maybe just they just have access to the cloud, they can be able to do their computation. So that's the main agenda of how KariRS Docker, or the reason why it came up with the KariRS Docker image. And one application, for example, like last time we did discuss about the uh, for for those we did discuss about KariRS web IDE. Currently, we have a web IDE, and literally, what happens is that you write code in your browser or from any place. You can write it from your phone, you can write it from your laptop on the internet. So you have your IDE where you write your code and you compile it. So under the hood, what powers that is the KariRS Docker image. Literally, without what we are discussing, we're going to be discussing today, what I'm going to be showing you today, the IDE that now people are starting to use for KariRS, the online IDE, you cannot have it without having this image. That's why you saw even the announcement with the Docker image came before the IDE. Just that the most of the time, if you already have your PC which is capable, you don't need to use the Docker. So literally, this one is not something it's not something you might use every day, but it's a good technology to understand, so that if you have an application where you want to use it, you can literally use it. And with time, if you become so good in using KariRS and even adjusting it, you can also build other stuff on top of it, because literally with Docker you can use an image to build other things. So I'll be explaining to you all this. Let me admit someone. Judith, you're welcome. So those are the basics before I even enter into what we are into the KariRS itself. So is there anyone who has a question so that at least everyone who is basically new to even the Docker technology can be at pace? Is there anyone who doesn't understand something or wants a clarification on something?
Hey, man.
Yes.
Hey, I love the vision you have with this one.
Who is talking?
You're speaking to her.
Okay, okay, thank you. Yes.
Yeah, I really love the vision you have with this. Mainly, you are anchoring on portability of the code, right?
Yes.
And then also splitting the CI from the CD, right? So
Exactly.
that someone can operate like much quickly in terms of software and hardware, which has been like a constant problem in like our IoT. That's why it's slow.
Yes.
But then, how are you planning to mitigate other problems, such as now someone has a piece of code.
Yes.
Uh, how how will how will they get the hardware eventually? Because in the Docker infrastructure,
Yes.
the main the main thing
Yes.
powering the ecosystem is that Docker gives the tools to devs, and then it kind of licenses or owns the people who can create the infra,
Yes.
and then in that way, or they could get donations, or they could get like they could sell licenses. That way, it enables like it enables that synergy that these guys have the compute, these guys have the tech, these guys have the app. Everyone can ride on it on the rails.
Mhm.
Now, in 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 embedded, you often have to have the physical access to the device,
Yes.
unlike cloud.
Yes.
So, uh, how are you going to mitigate that that like
Okay.
I don't know.
Yes. Okay. If I get you right, you're trying to
Yeah.
ask how do you get? Let me show you. So you have your code. Here, here is your code in the cloud which you have written, and you need that eventually this code needs to reach your physical MCU. Is that your question?
Uh, yes, I'm not really. My main question is
Yes.
I really don't understand the positioning of KariRS
Yes.
in the infra or even the market, like the real product positioning.
Hmm.
Because in terms of cloud,
Hmm.
those guys use those guys own the hardware. Like you can run your thing without like the physical, like to run a web. You don't really need the physical access of the web servers.
Yes.
But IoT, you often need the physical access of the actual MCU or SBC or something.
So let
So,
me.
so like what is Kari mainly trying to solve for now that like unlike cloud, you see, unlike cloud, Docker really solves it because the people who own the compute can be totally separate from the people who actually code. What about KariOS? Like, what is the positioning? Like, what are you really offering the devs
Mhm.
to like ride on? Like what is the real uh, proposition of KariOS? Or what do you see it becoming
Okay, so
apart from being of just deployment? Like,
yes.
how do you see it really coming up?
Okay, so number one, is that let me just start from the main. So the first thing we have uh, KariRS, which is Rust based, and literally you can learn it on your computer, literally to build your IoT project. Then we have this part where we are talking of bringing KariRS into the cloud by using the Docker technologies. And your main question is what actual problem is it solving to put it in the cloud? Is that your main question? Okay, let me first answer that, and then if there's still another question, you can raise it. So now, when we have KariRS being able to be available in the cloud, that is, we have a KariRS Docker image. Number one, it means we have a ready-made environment. You don't need to install, you don't need to do those installation of the dependencies for KariRS. Let me admit someone very fast. Okay. Uh, Joel, you are welcome. So literally with KariRS in the cloud or being supported in Docker, we have a portable environment. So you have a ready-made environment whereby you just need to spin up your container and you have everything working. Next thing is that you can be able to use these you can be able to have this KariRS image. You can be able to uh, pardon, there's someone who needs to mute their mic. Kindly, if it's you, Cheryl, kindly, you can mute your mic for now. Cheryl? Yeah, so with KariRS in the cloud, we have portability. We also have, you can be able to use it from any device. That's another thing. And then you can be able to you can be able to, at the same time, because there's another issue of if I wrote the code in the cloud, how will I get it to the MCU? Uh, if you had to write this code inside your Docker container, let's say it's running in your machine, and you use the KariRS Docker image so that you can have a portable environment. You don't want to do those installation in your actual machine. You just want to do the development inside a container. Then you can also be able to link from that container. You can also be able to link it to your physical hardware and still access your hardware. That is the advantages of these. Another advantage that I've already discussed with you is that this Docker image that we are looking at today is the same image that is powering the KariRS IDE, the web IDE. And inside the web IDE, you if you use the KariRS web IDE, you realize that you write your code, you compile it, and then you get to download the compiled binary, which you can then flash into your MCU using the KariSpark application. So that is the workflow. So you can be able to design it in the website or in the cloud, and then you get your final binary and you can be able to flash it later. So literally these are all the advantages, and you can also build your own if you want to have a more specialized environment of you want to automate more things more, and you want to use this framework. Then you have like a parent image that you can use to build and automate things that you want maybe to build for you want to build stuff using this framework. You can build another image for to be able to automate the things that you want to do. Have I still answered your question? Was it Warren? That's what we are going to discuss. Okay, yeah. So is there anyone who is because is there anyone who is lost? Who is even asking themselves what is Docker even in the first place? Is there someone who is completely lost till now, or anyone who has a question? Okay, I'll assume everyone is good. So to get started with the KariRS Docker, so the first thing is to search for Docker Hub. You can just open any browser and search for Docker Hub. And once you open Docker Hub, you have this link here, Docker Hub container image library. You can click on it. So I'd already clicked on it, so it should take you here. Let it load. It should bring you here to the Docker Hub. So this is Docker Hub. So if you have an account, you can just sign in. Now inside of here, you can come and search for KariRS. KariRS. And you'll find it here. So this is where you can get this image. It is the first version of the KariRS image, so you can see whatever it has. Uh, it comes in with everything set up, and the commands to start using it are well indicated here. So the first thing to get this image into your system is to run this command here, docker pull. So you need to go to your terminal. Let me just select a terminal. So you need to go to your terminal and learn that command. You should learn docker pull. Let me just copy it. So this is the command that you're supposed to run. Docker pull the Vincent, then KariRS. So literally when you run this command, it should pull for you the image into your it should get you the image into your system. Now for me, I already have the image. So after learning that command, this is what you should do. Then you learn the command docker images. So literally you should see that image indicated as shown like this. This is the image you'll have after learning docker pull. You should have this KariRS 1.0.0. That should be the okay. Let me admit someone. Yeah, people were still joining. Admit. Yes. So literally, when you learn this, after you run docker pull and then you list the images, you'll be able to see your image listed here. Vincent, like this, KariRS. So this you have already gotten the image. So from there are various ways to start your container. You could use this command docker run. You give it the name, and then you learn the bash. Now there is this option which is dit that way. So D means you are detaching the while explaining this, I'm assuming some of you are familiar with Docker, but if you have a question, you'll ask. So when you learn Docker run and you give this option, for I means you want to learn an interactive session. That means it will allow you to type in inputs, so which is what you'll be doing. And then T, it assigns for you a terminal for your container. Then this means it runs in detached mode, so it won't block your main terminal. So then you give your container a name, and then you specify the image you're going to use, and then you add this bash. to say that you'll be using bash. All then this is to start the interactive container, or else you can learn, and then after that you can do this. So let's just do it. So instead of just telling you what it should be or not, so we'll start by learning this command here and see what we get. So I'll clear the terminal. So when I try to run this command, already I had created that container, so it's already there, so I can't rerun that command. So I just go ahead and show you. I had already created it. So to list the containers that you have, you do docker ps all, like that. So this a means all. So I already have these. I already have my container here, which I had already in started. So that way you saw I could not when I tried to learn it, I could not, but I could delete it and learn that command. But after you run it, you should be able to have uh, according to the name you give it, you should be able to get uh, the similar container. So if I could, let me delete this so we can be at the same part. So you see Docker. So let me do Docker. Yes. So I have this here. Docker learn KariRS. Now already because okay, sorry, because now I can add those options that you have seen in the DIT, like that. Now if I could try to do this, so you see I hope everyone is following. I will show you the mistakes that some people can make and all those issues that you might come with. So if I try to learn it like this, you can see what I get. I get an invalid reference format to to whatever to what I had written here. And you can see it says you that the repository name must be lowercase. And that's why you see in here, even the name here couldn't be capitalized. So everything must be in lowercase after you literally build what you're building. So I'll go ahead and clear and Docker. Yes. Let's let's give our container something else. Let's call it carry uh, carry session 5, like that. You can give it that name. And so literally we've already now we've already started that container. We can do docker ps, and we can see that our container is already running here. So now from the documentation, I want to take you step by step so you understand what's going on. Then after you do learn this command, the next command is to enter the container, because you want to do the environment you want to use is inside the container. So here you can see the command docker exec, the option it, then KariRS, then bash. So literally docker exec command is used to execute commands inside your container. So here you'll be executing this command bash, and you'll be using the options in IT, that is interactive terminal. So that is what you're going to do next. So clear this and do docker ps. So from this command, just need to get the name. which I gave my container and replace it here like that. And literally now I'm inside the container. You can see even what the terminal has changed. I'm inside the container as root. You can see here I was inside the Windows machine, but now I'm inside a Linux environment. So once you enter the container, you'll find yourself in this location /embedded. If I do ls and to show you what is inside, you can see here we have the KariRS folder. So if I try to run Kari inside of this container, you can see it runs and it shows me the possible commands. So is there a question up to that point? Is there anyone who has felt lost up to that point? Yes, someone speaking?
I'll continue.
Okay.
I have some reservation.
Yes.
Mm, uh, I don't think this is the best DevX for this. I'm loving this tool. I love the idea behind it,
Okay.
but I think you need to do something small on the DevX.
Mm-hmm.
It's not ideal for you to IT into a Docker container to interact with Kari. You could expose a port, and the port could and maybe map a volume also, and someone can interact with it directly on the IDE or something if they need to.
Okay. Now, um, what you are talking about? Uh, okay, what you are talking about is uh, having the having a learning application which is mapping to this to actually this image or a container of this image. But what I'm showing right now is the raw image, the base image itself, before you even build any application on the top of it and exposing ports and all that. Because I believe for what you have talked about, you need to have a backend that is you are connecting, that is really running on that container, so that you can map ports for that communication. Whatever you're describing is like the way we do with web, like you have those ports of an application that is running and literally uh, you literally communicate with whatever is there, maybe from an IDE. That is what KariRS web IDE does. But here precisely we are going to the raw image itself. Before you add all those other things, you're going to this raw image itself. So that if someone else might say maybe the IDE tool that I've provided, maybe it's not best enough, and someone would like to say I'm good in KariRS, I can build something on top of it, maybe a better idea or a better workflow on top of the KariRS, then you're providing them with this image. So whatever you want to do, you can go ahead with this image. It's just the base image, the raw image itself from the which just has the environment itself. So then from there you can do something like that. The same way that we did with something like the one that is powering the KariRS IDE. It has a backend in which it exposes ports. But for this one is the base image, and that is what we are looking to add today. Have I answered your question, or it's still not clear? Okay. Yeah. Okay. Okay. Thank you for the feedback. You're still considering everything. So, uh, whatever, and if Anyone else has a certain feedback? Actually, if you've been using KariRS and you have any issue to report, you can just report it. So the next version will be, yeah, the next version will be coming sooner with fixing any bugs that have been found in the current version. But if you have any issue, you feel that you've done everything correctly and you have something you want to raise concern about, you can raise it in the group, or you can also mention it here. Maybe something I could just answer you directly, or if it's a major issue, you can look into it. So then next, we'll continue to uh, let me- yes. So we are inside the slash embedded ls. So here you can now from here. The thing about Docker is about the Docker stuff or whatever you are already done with it. Now from here you just do the normal things that you're used to do, building a new project. For example, let's just try to build a new project, and so that we can try and see how this container can also be linked to physical hardware. So we could try and go ahead to create a new project. So we go and type carry new, and we could give the type of board. We can go with the AVRMCUs. So we can try to use so for this KariRS, you can just tell it something like Uno, and it will understand you mean the Atmega 328p MCU, which many people just call Uno because of the board. So we can try build for that one, and we need to give the name of our project. We can call it uh, we can call it KariRS Docker. You can just write it like that. And literally it created a new project, KariRS Docker. So we can cd into that, KariRS Docker, and we can clear ls. So inside of here, you can see the folder structure of your project. So you can see we can enter into the source folder, clear like that. So ls. So we have this folder, and then we have our main.rs. So now, literally, in this container, since it's a Linux environment, if you wanted to install things like VS Code or all that, you can do. But for this one, it comes in with Vim, so we can just open VI. So if you are new to, if you are familiar with this IDE that or with this editor, if you are familiar with using Vim, then you can just use it. It's already installed uh, inside this container, so you can already find it. So I will delete this. Can also delete this. So you can see the folder structure is already generated for you after you create the project. That is something you always find when you begin any KariRS project. So let's just try and write a simple code that is literally not doing much. We can try writing a code that will print to our monitor, something like that. So we can initialize the serial. So we can type in. I hope everyone can be able to see what I am typing in. Hope the terminal is clear. Yes, so we can initialize serial. We will give it a baud rate of 9600. We will be using that is the most used for the AVR MCUs. And then from there we can try and print into the screen. So we'll do KariPrinting, like that. So we can say, we can literally run a message and say running, or let's say program written in Docker container, like that, like that. So literally we can just have this simple program which just does this program written in Docker container. Or if you wanted to even do much, you can maybe decide to spin up a scheduler here, carry async, like that, and we can do that. Now this is KariRS syntax, so this if you've been using KariRS, this one shouldn't be. So we can just call it this task1, or we can call it printer, maybe. Any name you give it, it's upon you. So like that. So then you can enter into the scheduler function. So inside here we can also decide to print something. We can maybe create a counter. We just want to write a simple program, so we can create a counter. You can say counter number is let's do something like that, and let's write here counter. Now after doing that, it means we need to create a variable known as counter. So I'll come here and say let mutable. We have to make the variable mutable because we'll be changing it. That's Rust's rules. So let's mute counter be 0, like that. So literally that is our program. So it will be counting, it will be incrementing the count here. Oh, if not, we are not incrementing the counter, we need to increment it. So here we will do counter plus or equals to 1, like that. And so this, what this code will do is that it will learn each 1 second. Instead of using delays, we are using this non-broken way, using the carry async. So after each 1 second, it will execute this function. So after each 1 second, it will increment the counter and print this. But at the beginning of the program, it will print program written in Docker container. So I'll go ahead and save that, like that. Then I can learn carry build. Sorry, I need to go back. Clear. Remember, when learning this command, you need to be in the root directory of your project. So like that, carry build. Okay, someone needs to be admitted. Let me check. Someone is joining right now. Or what did I hear? Okay. Okay. Or okay, not so. So in the first build, like always, you'll see it's compiling. The first build usually takes a bit longer than the other builds, as it compiles most of the dependencies that we've used. So let's wait for it to do so. And you can see these are better architecture if you just have everything compiled at the first time, and any other builds are just depend on your code. They are extremely fast. So let's wait for this build, for this compilation.
Hey, as I think builds, could you have a small, like a small chat?
Yes.
Okay, I've just gone through the project on GitHub.
Yes.
Okay, I'm more kind of experienced programmer,
Yes.
so it's not like I'm starting into this. So I just dove right in. So I see we already even have a CLI in the KariRS,
Yes.
like a native CLI.
Yes.
What we are doing here could have better advantage if we used a different approach. So
Yes.
we already have a CLI.
Yes.
Instead of uh, interacting with it inside the container, and within the container we have less tools to use, and it's not the best DevX. Just have it that you utilize the CLI natively, because CLI is not part of your offering as such. The main core offering is that you have your environment within, like KariRS helps to set up the environment within the Docker. Like it helps to create the image and then run the container, sort of emulation kind of thing. So instead of us interacting with it inside, the CLI is a dev tool. Let it remain on the outside. What it does, what it will do, it will rather orchestrate the creation of the image. And you see, even right now, we are building within the container. Once we drop this container, we lose every state that we had. So I'd rather we have it on the outside. We map volumes. You can just map the volume. Like even right now, we could have solved this phase with just mapping of a volume. Have you ever used Docker Compose? Docker Compose.
So,
Yeah, you could try check
um,
on that.
okay.
It,
Uh,
it can be a good tool to help us configure. So you can configure, okay, because Docker, you can still do it within Docker commands, but it tends to be tedious. So Docker Compose is more of a structured standard, like an industry standard to help you orchestrate containers.
now,
So we could do that, and then we map the we map the we map our source as a volume. We build the image, and we could even now take advantage of Docker Cache, because right now we we are always building the image every time, uh, and our artifacts, and then next we are working within the container. So once we are done, we lose all the states. You see the challenge we have, like right now. So check out Docker Compose, and then okay, I check this down, and I'd like even myself, once I get time, contribute to the project. I see it's open source on GitHub. Like really like, but not this part of the defects.
so
I think we'll need to. Hello, sorry for your PC. Hey, Vincent.
so Okay, I've heard what you've addressed, and once again, as I said, you are still in the middle of this session. All the issues you've mentioned are already addressed. You've not, I've just not shown you. You're still just. I'm still showing you part of all this. So all those issues you've mentioned, even about the container, after running the container, you lose everything and all that. We already have the mappings of volumes and everything, and is what I'm going to show you shortly. So literally, this is one way of how you could run a container. So the way I've shown you right now. So here we have not mapped any volumes, we've not mapped any physical hardware. So I'm sure I've just decided to take step by step. So one step whereby you just want to run something on the container and get away with it. I don't know. Maybe someone was just wanting to do that. Most of the time you won't do that literally. Most of the time you want to do that, you would like to map with volumes, which is really what is uh, in reality. But here I was just trying to show you one of the ways to learn this container simply. So then the next thing will be showing you how to map with the volumes. So now inside of here in Docker Hub, we've already shown that. So I'm going to take you step by step. So we've already done this one. You can see even I highlighted here. This is a quick start. If you just want to do a quick start to test, maybe you've just saw KariRS, you don't want to do much, you just want to see, oh, how does this image work? So you wanted just to do a quick start. So that's what we were doing. So you just create this one, and then you enter the container and all that. Now you see after that, that here is what I have written: working with project using volumes, and it is the recommended way. This is the recommended way that I've recommended. So this one was just to give you a quick start of maybe you've not had that much great interest in KariRS. You just want to see, oh, how does this tool work? So this is how you can do a quick start. So now next we'll be looking at working with project using volumes, and which is what is the recommended. So here is you mount a host directory so your project persists outside the container. So that means even if you drop the container, you still have your project there. And here is the command that you use. Now for people who are more adapted in using Docker, you can use Docker Compose. For example, that's what I use when building things, more complex stuff like whatever is powering the IDE. But for here, I'm just showing you simple Docker commands because you want to take everyone on board, even someone with not yet advanced. So we want everyone to be on par and have these and have a common ground to run this container. So this is a command that you can use. So we are literally, the only difference is that we are bringing on the fact of mapping a volume. So then you do this. So literally this is what you can also do, and we can copy this command instead of typing it. And then inside the container, you can see whatever is written. You can do your work there. You also have down here accessing hardware. So let's first see. Let's do all this in one part so that I think I can address everything at one time. So the first thing is that you can be able to map volumes. For those who are not familiar with volumes, uh, what we are literally saying is that whatever you'll be doing inside your container, maybe there's a project you've created, so it will be mapped to a storage inside your physical PC. So like even if you drop your container, whatever data you created will be inside your PC, not inside that environment. And it will be just be so the container will just be pointing to that data. So literally that's what mapping with volumes will be doing. So the other thing you want to do is to flash, to be able to write your code and maybe program it into your MCU. So for that, we include this option here, which is -device, and then you give it the port. This one is the port, and you'll use And if you're from Windows, now I know this will be a bit kind of like new, but you'll have to agree to this. You'll have to switch to WSL. You'll have to type this port in the form of in the Linux way, and I'll be explaining that why we do that in a moment. So that's why you see on Windows you use WSL, which is what Docker on Windows uses. Then so we'll literally go to this command so that I can explain everything at once. So let's go back here. Let's just leave this container we had created, and okay, this is so. Let's write this command. So docker run dit docker run. You can give it a new name. We can say KariRS volume mapped. But before we even write this command, because since we want to literally also map our hardware here, we would literally not want to write it inside this terminal. Now, if you are on Linux, it's not an issue. You can go ahead and write that command. You can go ahead and write this command and then be sure of which port you are in. But if you are running on Windows like I am, then you have a bit of a you have to find a way to go around this. So one of the first thing is you would launch WSL by typing WSL. So I've already launched that in another terminal shell inside here. So I've already done that in this other place. So that is something you can literally do. But again, now when you are inside WSL in Windows, let me address this one for the people who are in Windows and they want to use this one to map the hardware. If it's just volumes, that's not an issue. You can just do it on the Windows terminal. But if you want to run this command where you'll be mapping the hardware, you will go to WSL, and here and inside of here you would need to give access to the actual port that you are using. Now inside of Linux, those development all those ports that you use are inside this folder dev. So if I ls into dev, you can see all this. You can see all these ports, TTY, all of them. Now most of the time you will find your MCUs having this TTY, something like AC, and then something unique following that. So this you would look for something like that, AC, something unique at that. So right now this one is for the people who are coming on Windows. You'll have to, if you go this route, you'll have to take this costs of checking out this. So you literally can see inside of this this dev, you can see we don't have such kind of of uh, a pattern inside of this dev. So there's no way that we have any access to hardware from the physical PC inside WSL. So you need to literally, the first time you need to map physical hardware from, or the port, you need to allow WSL to access a port from your physical PC, because by default WSL has no access to the ports which are in your Windows machine. So how do we do this? So let me clear this and let me go to the Windows terminal. So inside of Windows terminal, let me get an MCU to connect to so that we can see what will happen. So I'll connect microcontroller. So we'll be using this MCU. I'll be connecting this one, is a nano. This is what I'll be connecting. So let's connect it.
Yeah, how much does that go? How much does that cost locally?
For a nano board locally, it costs 1,500, 1,500. But this the prices for electronics keeps changing. There's times you can get it at 1,200, 1,100, depending on the store. We have a couple of stores, so they keep the prices aren't always that stable. But it,
You sell also directly. You yourself.
me myself, I don't sell directly. I also purchase them. Yeah, but
What are the recommended places to get the I know the Uno and stuff
yes,
could be easy to get, you could even import, but then
yes.
what about these other peripherals, the extra boards, um, uh, like MOSFETs, like any experience? Where have you?
Okay,
Is it a good seat locally?
you see these online stores that sell these microcontrollers. They do also sell all those other peripherals.
Uh-huh.
And you see, like for example, if I could mention Nerocas, because I've done a couple of purchases from them. Nerocas, you know of Nerocas? Like if you check out how Nerocas operates, they do sell the MCUs and they also sell the peripherals and all that. And so you can purchase from them, and they do deliver countrywide. So you can purchase from them. You can also reach them via call, and they will give you a good service. So there are various online stores which you can purchase these MCUs. No, no, no. Actually, it depends on where you are. It depends on where you are, but delivery costs are never not expensive. Yes. Yeah, actually, I can see Paul has dropped the link. You can just click on that link for Nerocas. You can check it on the chat. Yeah. So now back to this, so that we can at least move fast. So right now in the main physical Windows machine, if I was to learn carry detect like that, you can see I can see the MCU that I've just connected. It is in the COM port 6. It is in port 6, the communication port 6, this COM port. So now, but when I go to the WSL and I do this to try and find that pattern I've already shown you, I see there's no such pattern here. I can't see such a pattern here. So it means WSL has no access to these ports. So inside of Windows, we do use a tool known as USB IPD. So you can see the description. It is a tool that shares locally connected USB devices to other machines, because uh, WSL itself, it's running its own environment, like another machine inside your machine, something like that, virtualization and all that. So these ones enables for sharing of USB devices between those machines. So that's why you're being told, including Hyper-V guest and WSL2. So that is where WSL2 comes in. So you can share whatever you have using this tool, and that's what we'll be doing right now. So you can see the various commands that are available. You can use attach to attach a USB device to a client. You can use bind and all that, but the most important thing you first have to do is to do USB IPD list. Sorry. List. And once you do that, it will show you the ports which can be shared. So the first one you can see is the one that we have connected, which is the USB-C, which is the USB serial converter or whatever. So if you wanted to confirm that it is it, if I unplug the MCU and we did run this, we can see that it's not there. The USB serial is not there. So if I take it back, if I connect back the MCU, and we did run this, you can see now it's there. Now it's important to understand here. Now if you're using Linux purely, this, do not even disturb yourself with this. But for the people in Windows, just follow along. It's it's just it's it's also cool to learn new stuff. Maybe you won't be using this, but maybe you're someone who just want to do things native. But if you wanna use this, you wanna run maybe these codes and do stuff in containers, then it's good to understand this mapping. And actually, even this knowledge is transferable. If you're not even just doing KariRS or other stuff, you have learned how to map ports from Windows to your WSL machine. So literally. So when you look at here, we have a bus ID, and then we have the device, and then we have the state. So you can see now the state here: not shared, not shared, not shared. Now we are not interested with these two. We are not interested with that one. We are interested in this first one, which is, yes, pardon. Oh, okay. So we can see we have this bus ID and we have the USB serial converter. So after listing, what we want to do is to do USB IPD, and we want to change this one from not shared. We want this one to be shared. We want to give it to the WSL. So we want to do USB IPD, and then we want to hyphen attach. Pardon. Someone. Oh, uh, can you hear me now? Uh, 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 there's someone saying, okay, yeah, okay. Thank you for confirming. I saw someone say that they. I don't know why someone said that they can't hear me. Yes. Hello. Yes. Can you hear me? It must be. It might be your side, because Paul is confirming he can hear me. Hello, we can hear you. So literally this is what we're going to do. We have this bus ID, which is what we have to share with WSL. So we have to attach it. So we attach and we attach into WSL. So we do hyphen hyphen WSL, and then we give the bus ID. It can give it with this option hyphen B, meaning the bus ID, or you can write it as full hyphen hyphen bus ID, but you use this short notation. So now you need to know the bus ID of the device you want to give. So the bus ID is given via this syntax. For example, the bus ID for a device is 1-1. The bus ID for this wireless Bluetooth is 1-7. The bus ID for the HP HD camera is 1-9. So those are the bus ID. But we are interested in this bus ID 1-1. So that I have modified this one to 1-1. So most of the time you might not even have all these commands in your mind, like, because usually you can write them down or have them somewhere. So let's have USB IPD attached. So let's run that one. So you can see what happens. It says USB IPD device is not shared. Run USB IPD bind as, I hope you can see my screen, as administrator first. Now USB to perform all these to perform attachment and detachment, I should have mentioned this. When you want to perform these ones, you should be in administrative mode. But it's good that I've shown you that if you try this one here, it will be an issue. So you have to be in admin. You have to have the, like, the root privileges or the administrative privileges in Windows for you to authorize for the detachment and attachment of these peripherals. So what I'm going to do, I'm going to go into Windows, and for most of the time you're used to doing Windows PowerShell, which is just the normal one. But now for these privileges, you need to go with Windows PowerShell admin. So we go as an administrator. So you'll be prompted by Windows like that. So now we can do USB IPD list. So we have them like that. Then let's try attaching. And so literally for the first thing is that it is not shared, so we need to bind it so that it can be shareable. To make it shareable, so we just go ahead with this command. So I've told you these commands, some of the times you might write them down, but if you just go ahead, if you're just good writing them each time, they just stick up. So you go ahead. So we do the binding, and then after doing the binding, let's clear this, and let's run the USB IPD list like that. So now you can see after doing the binding, we have this one as shared. So now we have made this one USB shared. Now if you wanted to make it unshared, you can just come here and say you want to unbind like that. And now if you come and check the list, it is not, it is not a shareable device. So the first thing is to make it shareable. So you do that with USB IPD hyphen hyphen. Someone is, oh, okay. Okay, let's first list it. So you can see it, oh, okay. So you can see it's not shared, and I've said to make it not shared, you are using this command unbind, which is literally the opposite of bind. So So Paul, can you see my screen? Okay, you can see my screen. Yeah, Paul, you can see my screen. Paul, are you with us? Okay. Okay. So literally, let me just type it up, or let me just move the commands up. So we were saying the first thing, like literally this is the default state of the peripherals in your machine. So they are not shared. They aren't shared. And USB IPD only shows you the port which have the ability to be shared. But by default, they have the not shared status. They are not shared. So for you to be able to share them, you have to bind them. And you bind them by giving the bus ID. And I told you that the bus ID is here. It is given as 1-1, or according to the bus ID that will be assigned by your device to all the various ports. So here we are going to do the binding, and if we do the binding for our MCU, which has been classified as this with this device name, if I click enter like that, and let me clear, and I do USB IP list, now you can see now it has the ability to be shared. Now we can share it. Now let's now share it. Now to share it, you do USB IPD attach, and we are attaching it to what? To WSL. And then we give the bus ID. Now you could either write bus ID like that, or you can just use the short notation of -b like that. So we give the bus ID, which is 1-1 like that. So I click enter. Now you hear that sound now. Now that means that this device is no longer owned by Windows. Now if we try to like go here and check its state, it says it is attached. Now if I go down here and okay, let me clear so that we cannot have all. Let me just run the command here. Carry detect. You can see carry detect cannot see any port, whereas the MCU is still connected to the machine. That is because that port is no longer now available in Windows. It has been handed over to WSL. The moment you attach it, it is handed over to WSL. That's what attached mean. Now, the opposite of that command is basically to detach. Sorry, I've put should be single T. Let's see. Yes, like that. So now if we do USB IPD list, we can see it is shared. And if we do carry detect, we can see now it's back. It's in Windows. Yes, it still has the shared status. You can share it. You have enabled it to be shared, but it is still under Windows. You have not given it to any other machine. So but our case, we want to give it to WSL. So I just go up the commands and attach it to WSL. Yeah, so it's already attached. So now let's go to the terminal for the WSL, and if I just go up, do that one. So inside of here, we should be able to see it, and here it is, TTY USB 0. So you can literally, we have USB 0, we have AC. So and if you're not sure of which pattern to look at, you can always, like, if you ls dev, for example, right now we know that it is mounted inside of WSL. Now if we unmount it and ls dev, you'll see that this one would disappear or you will not find it. So that's the first thing maybe you can do, check which is the new port in the dev, and you can realize that is your device. So now let's continue. Now that you have your device, you can now come back to this command, docker run this command, which is here. So you need to you need to do docker run this, then you give the name of your container, then you give the device. We already now know what our device will be, so let's try writing that command or copying it, though we need to modify it. So let's create a new container. Carry, call it carry mapped, like that. Then we've seen that we are TTY USB 0, and then our volume, yeah, I think we can go with that. Okay, so if we cd into root and we ls, so okay, let me go back. So we've already done the mapping here for the volumes. So right now, if we decide to go ahead and create and enter into our container, we have called it carry mapped, exec carry mapped bash. Oh, sorry, in interactive mode. Yes, now we are inside of our container. If we go to root and we ls, we can see this workspace, which is where we mapped into. Now if we cd workspace, we can literally see it is mapping, it is actually mapping whatever we have in this folder. This is a project known as Hydro. Okay, so this Hydro project is literally in my physical machine, but now the the this workspace folder here is mapping to that project. So it means, like, if literally I could try and learn carry build here, let's see. Let's try doing kari build, see what's the issue that it encountered. And it tells us that failed to load source for dependency. Yeah, you can see. Yes, so you can see it is the path which has an issue, and uh, that's why we need to just go ahead, and inside of here let's just exit, because I don't want to mix those project. Let's cd back. Let's like go back once, like this one. And after going back once, let me make a new directory here. Make directory. Let me call it session 5, and cd into session 5. Now we are inside of this directory, and so we can go ahead. So let me go docker stop carry mapped. Yes, I can go ahead and stop it, and I can say is it carry? Yeah, let me see. Yes, and if I do docker yes all, I should have carry mapped not in the scene. Yes, so that I can literally go ahead, and inside of this session 5 I can go ahead and let me go up to our command that we just used. Yes, this is a command, so can go ahead and enter like that, and if I exec and I cd to slash space. Yes, so now inside here I'll create a new project, so carry new, and I call it, I'll go with the uno nano. I'll use the same MCU, so there's no problem. So then I can call it mapped, this new project, call it mapped like that. So if now I ls, I can see mapped, so I can cd into mapped. So now we have created this one inside our root, inside this workspace. We want to believe that this project was created inside our Windows machine, because that's literally what volume should do. So let's go and let's try and see. We were inside the Rust folder. Let's look for it. It's in document. We go to Rust. Then we created something known as session 5. Session 5. So this one we did it in our machine, but the mapped is and literally here it is. What we have created inside the container, the project is already inside, meaning we have already successfully been able to do the mapping. Okay, so if you are to open something like the cargo.toml file here, like this, you can see now we can't have the issue with the pads, because the project has been created in the Linux environment where it is, which is where it will be run, which is where we will run it. So now it means whatever I create in workspace is actually mapped to this folder session 5. So even if I was to drop this container that I'm running on right now and delete it, of which I will do, you will see that all this data will still persist. So now the next thing, this is not the main thing, is to be able to see how we will flash our code. So let me cd into source and write a simple program as fast as we can, so that we can wrap up with the session. So I will theme into main.rs, and inside of here, okay, I can just do like that, like that. Okay, let me spin up a scheduler because fast. KariRS. Can do it for 1 second. It'll be good. We can call it counter or printer, whatever you want to call it, like that. Let's write counter. Counter like that, and it's going to do counter plus or equals to 1 like that, and then this side here we need to initialize the serial. So serial, this serial, so we're going to import it of 9600 like that, and we can do play train. Program written and executed in KariRS Docker image. Okay, like that. So don't think there is anything to add. You can just okay. We've not created the variable, which is very crucial because without that you'll get an error from Rust. So let's mute counter equivalent to 0 like that. Yes, so that one should literally work, and then you can go back and do build.
What will happen if we try to read any IO from hardware?
Yes, pardon.
What will happen when we are before mapping before mapping to the board?
Yes.
What will happen if we try to address like a signal
You see,
connected? It stop. Like what will happen? Or we just not get any signal? Like let's say we want to get a hardware signal from maybe a particular.
you see, the way KariRS is designed, the KariRS CLI, it has a way of checking at compatible ports for the boards. These devices that you're using, they have a certain signature that they have. So if KariRS can't find compatible signatures, it won't even dare run, because you are literally trying to tell it to access something that is not there.
Think before you map to the board, before you deploy your code to the board.
Yes.
When you just run it,
Yes.
like the example you gave, the example you are running is just a counter. What
Yes.
about if we want to run something more sophisticated?
Okay, can you rephrase the question? You mean if I try to access the monitor before uploading any code? I mean the MCU. Okay.
What if you try to upload a bot before uploading to the MCU?
You try accessing the hardware ports.
Yeah. Because this code is internet running in the MCU,
yes,
right?
Yes.
But you're creating a virtual environment, right?
Yes.
So in the virtual environment,
Yes.
what happens when you run and then try to access link? maybe like a serial port or something. What will it do?
Now, if the serial port is available, it will be accessed. But if it's not available, the program will just stop. It won't do anything. So it first checks the availability, because if it
Still must have your hardware connected.
okay, if you are just compiling code like I am doing right now, you do not need your MCU. You will, after this, you will see where the MCU is needed. The MCU is only needed when you want to compile or send code or get signals from the hardware. If you are not yet, if you just want to compile your code, test it, debug it, and not do the hardware test, then you do not need to connect the MCU.
Okay, that was even my initial concern of like sometimes to sufficiently complex code, you'll probably be accessing some sensors on the IoT. So if the virtual environment does not provide for such, you still almost need the board always.
See,
So that's asking like what does it solve? In the first place, you still needing to have access to your board.
the code you are writing it to go to the hardware at the endpoint. So that's when you will need the hardware. But while writing the code, and you just want to write the code and test whether the code is functionally correct, you can like create virtual, you can like test your functions that you've written in your code using like dummy data. You can just write like functions, try to see how they are replying. But now when you go to actual like I2C and all those other communication protocols that you want to test, that's the time now you'll connect your hardware. Yes, have I answered your question? Okay, so we can see that the compilation is finished. So ignore these warnings, they are just there because okay, KariRS is still in development, so there is many parts that have not yet cleared, but these warnings are just warnings, so just ignore them. So you can see it has finished building. Now, if I was to clear this and try to build again, you literally see that it will build exemplarily faster. It won't take as long. So let me first stop that and first ls. Okay, so now let's try running carry detect like that. Now you can see now, because we already mapped, we can see the port that we need. It is /dev/tty USB 0. So I'm going to copy this, Control C. Now before I put this code or I compile this code to the microcontroller, I want us to see what currently is in this MCU. So I'm going to spin up a monitor, carry monitor like that, and I'm going to give the baud rate that the MCU is using. This MCU is using a baud rate of 9600, and then I'm going to okay, I need to specify the port. You can see KariRS is reminding me that, so I'm going to give it the port so that it can stop shouting at me. So you can see currently this MCU has a certain program which is printing values, but these values were coming from a certain pin in which a sensor should be connected. So you see it's printing for us dummy data. So this is not the program we've written. So now let's stop that and now set our code inside the MCU. So I'm going to do curly flash. So this one should go ahead and set our code to the MCU. So you can see it compile setting the code, and you can see program was flashed successfully. So now we can clear. We want to see what now we will be getting. So let's see whether we get what we've written. So Kari monitor, and there it is, program written and executed in KariRS Docker image, and we can see the counter is here. Okay, sorry, where is it? Yeah, here we can see the counter incrementing after each 1 second. Counter 0, 1, 2, 3, 4, 5, 6, 7, 8, and you can see all that. So literally, this is how you can do your development inside the Docker, the Docker environment. Now let's leave this Docker and drop this and drop this thing and delete it and get out of WSL and see whether we will find our MCU running the same program, of which literally it should be, because you have already taken the program into the MCU. So clear, I'm going to exit from here. Then I'm going to do okay, Docker stop. What was it? It was Kari mapped, the container we just created. It was Kari underscore mapped, like that. You can go ahead and stop it, and even remove it. Actually, let's even remove it to make sure it doesn't even exist, like that. So if I do docker ps all, like that. Oh, sorry, I mean docker ps, like that. You can literally see we no longer have that Kari mapped container. It's not there. So okay, yeah, it's not there. So I'm going to clear. Now let's see in session 5. Okay, even let's exit WSL for good. We are back into the Windows machine. But if we go to our folder, we can see we have the mapped. And if we want to see the compiled binary, it is inside .build, and here it is mapped.hex. This is the most important file after you do the compilation, because you can take this file and you can program it into other MCU. We previously, you can check out KariSpark if you've not. It is a tool that I developed for this. Like, it doesn't matter whether you wrote the code in Rust, in KariRS, in Arduino, in whatever language you wrote it, as well you compiled it to a hex file, you can be able to upload it into the target MCU. So that is where you get your compiled program. Now inside of the Windows MCU, of the Windows terminal, let's try to spin up a monitor and access. But currently, if we were to do Kari detect, we have no access to the port. So we need to bring them back. We need to bring the access to the ports back to Windows. So we are going to do USB IPD. Oh, let's first do IPD list, like that. Then USB IPD detach, and I need the bus ID, which was 1-1, like that. Now I've brought it back to Windows. Okay, so if I do Kari detect, I should be able to see it. Now, it's a good practice. If we are done with all that, it's good to also remove unbind this thing, return it back to not shared. So for that, I can do USB IPD unbind WSL for the bus ID. Let's so literally this I've not entered the, we need to be in the we need to be in administrative privileges for this. Yes, here. So USB IPD and bind 1-1, like that. So if now I do USB IPD list, you can see it's back to not shared as it was. So now I can clear that. Let's go here and here, and now let's try spinning a monitor. So carry monitor, and we're going to tell it the baud rate is 9600, and we give it the port. We know the port is COM6. I think that's what we saw. Yeah, like that. Yes, and we can see whatever we wrote in the container is and programmed to the MCU is currently what is running in the MCU. Now, someone might ask why we keep giving the monitor. If you don't give the monitor the baud rate, it will default to the default baud rate, and the default baud rate is 115,200. So the result is either you get garbage characters or you get nothing. Now you can see for carry monitor it will give you nothing. So you need to be very careful on. You need to always know the baud rates, that you need to always give it the baud rate that you are using in your MCU, in the MCU that you are connecting with. Now, is there any other question? Um, I think most people have already left, but I think we've covered most of what was needed if you wanted to go this route of Docker. So if there's anything about Docker, you can check on this. And also I've had remember KariRS is open source, so if you get good with Docker and you think there's a way you can make it better, you have ideas, or you can build something, maybe you can even build something and communicate, you're very much open to that. So that is how we do the KariRS image, or use it and spin up containers. So if there's any question you can ask about what you have discussed right now, if you have any question. Anyone with a question?
Just excited about the thing.
Yes.
You have something good, like you have something really good.
Yes.
It might need some polishing so that it is more friendly.
Yes.
Like the things you mentioned about mounting attaching the hardware on Windows, mounting on the place. I think that is pretty easy to include in the CLI.
Yes.
What I'm thinking is like you're trying to create an ADB for embedded.
Yes.
You work with Android, right? Like development.
Yes. Hello, you are
You see the
getting,
way
yeah,
ADB.
pardon, you are talking, you are getting lost. Hello. Yes. Yes, I can
I'm
hear you.
saying it's raining over here.
Okay,
So
okay, okay, okay.
what I'm saying,
Yes.
it's like the vision of like I really, for me, I really connect with this because it's not something that I've already been searching for.
Yes.
Because development in IoT is a bit choppy.
Yes.
So that is what got me interested.
Yes.
But then getting on projects, I see it's like the vision is not very clear right now.
Yes.
That's why I've even been asking those questions.
Mm-hmm.
And then the other thing is, okay, for me, what I'm understanding what you're trying to go towards,
Yes.
like you're creating an ADB
Mm-hmm.
for like IoT development, right?
Yes.
You work with
Android.
like development.
Yeah. First with Android development.
Yeah. So Android has like a tool called ADB,
Yes.
and it manages both your virtual environments,
Mm-hmm.
your virtual devices, and also your hardware. So the emulator and the hardware.
Yes.
And it even supports the detection and all that whatnot.
Yes.
It's like I'm saying, even mounting the device,
Yes.
it's an easy win. We can have an easy literally just a project build. You can even build like you did, like you said, you have the Spark that can deploy to whichever environment.
Yeah.
Just build natively or do what you can build, and let it orchestrate the connection to your environment, be it virtual or be it local, and then you just run the thing.
Okay, so
You're getting how I'm saying it about.
yes, I'm getting your idea. But I also hope you understand that KariRS can run natively, not just on Docker.
Yeah, that's what I'm saying.
For example,
We even put native. It's much easier than having to go through the hoops in terms of Docker and all that. And then you just have a CLI to help someone. The things that pain points that someone doesn't want to really grind into at the start, you just automate them into the CLI and just provide tools within the CLI.
yeah,
So I would like onboarding to KariRS, like you just create a project, create new, and it's just fun. If you don't need to fit it along with anything, and it just does it for you and then explain to you. And then as you learn and grow, you now understand why it did this and that.
literally,
Okay, still getting
can excuse
to
me?
have to understand
Um, yeah, I'm getting you. Hello, can you hear me? I'm getting you. But you see, most of the issues you are pointing out have already been addressed. Have you used KariRS by any measure? Have you like looked in or built a project? Like for example, like I've heard you mention that when you create a new project, should generate a template for you, right? You mentioned that. But when but I literally did that here. I just load Kari new and it did generate a template for you. Yeah, for example, I don't know whether VS Code here is on. Let me just switch. For example, you can see this code. You can see my screen right now. For example, this is a project I was working on using KariRS. You can see it's code here. Now, this project, if the moment you let me just uh, let me just copy all this. Let me just copy all this for just a moment. Then we wrap up. So the moment you create a new project, you usually get these templates, which looks like this. FN setup, and then you get something. Uh, usually get a template that looks like this, and here you have usually have these uh, comment that tells you where which code where what each part does. So if you look into the documentation and you see about the KariRS application structure, you realize that whenever you run the command of carry new, it usually generates for you this a template. So I think we have already addressed that for templating.
some command
Yes.
like check the hardware is where I was
Okay.
saying
Okay.
make
Okay.
it CLI so that you can just run and it automatically detects the hardware like natively, and then if it needs to mount them, it mounts, and then it could also help you to unmount safely because as a newbie probably you forget, and now
Instead, we have the CLI handling everything.
you
Okay. Okay.
yeah,
Okay. That's something amazing. Having the CLI handle everything. Um, but again, yeah, it's a very good thing actually. So we can consider that. Can consider that. So, is there any other question? Okay, is Paul with us?
I really love what is
Yes.
I hope to see this bigger.
Okay. Okay. Thank you.
Where would you shops stock things like and
Yes. Yes.
do they have to import every time? Like sometimes you